Jacob.
Good afternoon. I'm Jacob Williams. Dr. Garrison is my advisor, and I'm the student worker in the chemistry department. So we just want to really encourage you guys as a department and just as a class, as you're learning chemistry. There's a lot of new concepts for some of you. Some of you it's maybe familiar material. Some of you it's stuff you learned but need review on. So with all of that, we would encourage you to come to the chemistry department. There's 4 and 5 where we have lab. In the chemistry lounge, there's pretty much always a student worker at some point throughout the day, until about 8 o'clock in the evening and sometimes later. Many of those student workers will be clocked on and ready to help you if you need help. So anytime throughout your day, you can find a student worker, and as long as they have a few moments, we'd be glad to help you. In addition, we have study sessions at night. So tonight, Wednesday night, from 6 to 8, I'll be proctoring a study session just for Eugene Chem students. So please come. If you're struggling with something, maybe you like, oh, I got this, but you guys have a test, right? Coming up Friday. You got a test the next class session. Maybe there's something you're a little unsure of, or maybe the whole thing, you just don't know. Come to our study session. We can help you with that. Definitely would love to give you guys some help with that, especially since you'll be getting back to labs from, I think, the last week or so. We're trying to get those graded for you. If you have any questions about those labs, feel free to bring them in. Definitely talk to Dr. Garrison about those, but if you have questions, it's possible that us student workers could help you understand the concept for sure. If you're struggling with the lab or exactly what information you guys want to put down on those. Definitely would encourage you with the labs. Dr. Garrison has gone over this a few times. Make sure that you follow that rubric pretty closely. The labs spell out very clearly some of the things that are supposed to be done, and just throughout the week as we've graded those labs, we've noticed a few things that are missing that are pretty obvious. So just be careful. I would encourage you to definitely print off and read your lab at least once before you come to lab. Don't come to lab day having not read your lab. That's not a good business for yourself, because you're very unprepared and you feel confused throughout the lab, and then that's bad business when it comes to grading it too, because you lose a lot of points. So just encourage you with that. You guys are doing great. We're already almost, a quarter of the way through the semester. So keep up the good work. Come to study session, print off your labs early, and hopefully I'll see you guys in the department tonight. Thanks.
So, to encourage more use of the study sessions and those types of things, then on the 25th, which is a Friday, right, there will be a test. So 1 week following, normally it's a week or a week and a half following the quiz. Based on where I'm at in the material, I feel like that a week's going to be a good time. So, and it'll be over chapters 1 through 3. Friday, September 25th. Cool?
Hopefully that's the day I'll get right out to the home.
Maybe for the semester.
No, I'm waiting for the weekend.
Oh.
Like, just,
Oh, so the following Saturday, you guys may get released to go home.
that's the end of phase 1.
I'll pray for you guys. Okay?
Please pray for us.
I'll pray for you guys that you get that lazy to go home. I'll be here. So I talked about this in lab yesterday. My daughter officially has COVID. Her basketball team, most of it, has now become positive. They have scrimmaged a number of times and passed it among themselves. And so she is in isolation for at least 10 days. So it does happen to real people. She is not coming to my home. My wife and I agreed that that wasn't going to be acceptable. So we made other arrangements for her. But anyway, so it's really here. It really does happen. And hopefully her basketball team will recover and be healthy. So I wanted to show you something. I'm having trouble. I need to talk to our computer center about this, but I wanted you guys to know that I'm not trying to be really disorganized in the handout section of either one of the sections, but when you go to order those, it doesn't include the things that I put in by units. And so I can't, and it's just randomly placing things among this, right? Does that make sense? So either I need to move all of these up front somehow, but everything I try doesn't work. Does that make sense? So Campus Web can be that way sometimes. I'm trying to come up with a solution. Ultimately, I'll get all of those files moved over into the weekly units, and then these sections can disappear for the most part. And so I think that would be helpful. Does that make sense? But I just wanted you to know that I've been working on that, and I have been moving files up into those places. And so anyway, I also want to go down and talk about some things that have been moved up that might be of use to you if you're struggling with conversions and significant figures. And there's a worksheet in week 2 which would correlate to that material. It has answers to it, okay? So you can go in and practice those conversions if you would like. It's a random worksheet on doing unit conversions, okay? And if you go on down, then I also have in week 4, don't forget the Mendeleev worksheet that's due this week. But I also put in this is from our adjunct, and he uses some of these POCL assignments, and I really like this when he showed it to me, and he sent it to me. But it's on mass spectroscopy, and we talked about using mass spectroscopy as a tool, and you know those calculations that you might be struggling with, the 2 variable equations, this kind of comes from a different direction. It comes from the analysis side of that, and so that you would look at a mass spectrum and from that calculate the molecular or atomic mass for a particular element, and so it comes from that. So I put that worksheet there because it might be useful for you to look at, but that's up to you. I also added in week 5 some how to name compounds, and these are practice worksheets. One of them is from Dr. Easton, the other one is mine, the chemical nomenclature worksheet. And I encourage you for sure to look at that one, and because there's some caret associated with that, right? And you'll find with some of these worksheets that there's carets associated with them. And so I'll encourage that, the chemical nomenclature worksheet. And so that's one I made. Dr. Easton had one, and so I posted it. So if you wanted more practice problems, you could have those, okay? Some people like to practice a lot, and they always ask me for extra resource. And so some of these have answers, and some of them don't. There's also some practice for assigning oxidation numbers. And then I also have the 2 practice tests there, the chapter 1 and 2. Hopefully you're looking at that. And the 1, 2, and 3. From 2018 as to what my questions are going to look like. I took a couple of these questions today and altered them. For example, just changed the numbers in one of them so that the answer would come out different. Same calculation, right? But just a different result to a different correct answer. And then others are new questions that you wouldn't have seen yet. But a mixture of those. Okay, it's hard to teach for 20 years in the same topic and come up with brand new questions every year. It just seems a little bit ridiculous to do that, right? So I recycle, I guess is what it's called, and I'll do the same for you guys. So be aware of that. And then I always steal 1 or 2 problems from sapling or sapling type problem, right? I don't use the exact problem because that'd be a copyright violation, but I pull 1 of those or 2, and many of those are from our textbook from the end of the chapters, but I also take the end of chapter questions or in chapter questions and turn those into quiz or test questions. So if you're asking where to study and what to look at, well, that's where those questions are coming from, is from that content. Cool? Is that helpful? The quiz itself today is going to be, that we're going to do Friday, that I wrote today, is 1 page of math and short answer, a page of multiple choice, and a periodic table. So 3 pages of content, right? The test will be 5 to 6 pages, just to let you know that it's going to be longer than that. Usually it's about know, five to 6 pages. So 2 to 3 pages of math and short answer, and then the remainder in multiple choice. Okay? Questions, comments on that? So I was just showing you where we had some additional information on Campus Web to help you study for that. And I'm starting, like I said, to organize some other things to try to get the folders to look better. It just takes time to do that and to build it. So anyway, any comments on video, those types of things? No? The newest lab quiz went up. Be sure if you're in lab on Thursday that you do the one liquid phase diagram. That's the quiz that needed to be done for this week. Next week it will be a stoichiometry by continuous variations, which is the one that when you look at the video it has the spectral picture right at the front of it. So that one is for the following week. Just to let you know that. Make sure you watch the right one. All right. We stopped, I think, on this slide last time. Is that correct? Yeah, that's right. I remembered being. And we were talking about ions and electrons, and we started talking about something called the octet rule, which you're probably familiar with from high school, or most of you are. And the octet rule is talking about the valence shell of electrons, right? And so if I'm doing main group elements, then that starts to apply. This slide is actually showing the total number of electrons, right? Instead of just the valence shell. And it's showing the total number of electrons for a chlorine atom, right? And then it shows it for the chloride ion. Do you guys notice the distinct transition in name from one to the other? It's actually really important to notice because the chlorine atom has 17 electrons in its valence, or a total of 17 electrons, 7 in its valence shell, and the chloride ion has 18 total electrons with 8 in the valence shell. You guys with me? So there's a change in it to make it something different. When I'm looking at an element on the periodic table, am I looking at the atom, the chlorine atom, or am I looking at the chloride ion? The atom, okay? And we sometimes confuse that because we learn these cool things which are really helpful, and the cool things that we learn that are really helpful is that anytime I have something in this family, then it's -1. Right? Well, when it becomes an ion, when it makes this change, then it becomes -1. You guys catch the distinction there? And so I want to make sure that that's clear, that when we look up here, we're not seeing -1, we're seeing an element that will accept an electron to become -1. Okay? And the same thing over here on this side of the periodic table, we always take those to be +1, right? But if they form a +1. When I have sodium metal, it is not +1, okay? It's 0 in terms of its charge. When I have chlorine gas, Cl2, it's 0 in terms of its charge. Okay, it's in its elemental form. It has a 0 oxidation state. When it becomes an ion, gains an electron, or loses an electron, then, right, there's a change that has happened to become something else. And I think that's a really important distinction. And then we can go on and talk about the charge or valence that forms on ions. And so when I'm looking at families, then this is -1, this is -2, this is -3, plus or -4, +3, funny stuff there, +2, +1. Okay, you guys with me? Now, when I get over here actually, and I'm going on down, I get to aluminum on down, right? Then these are all +3. +4. Well, I have to look at that and think about that. Here, there's an easier way for me to remember those. Each one I know individual. If I build a compound, let's go right here. This picture really shows it, right? And so I get over here, then it's plus 3. Oh, wait, no, it's not plus 4. It's what? Plus 2. Right? So you can't count anymore to know the family. You have to be aware of where you're at on the periodic table. And those rules are very useful, but they don't apply to all elements. You guys with me? So, and, well, we can see the -1, -2, -3. Look, they'll put those just in blue. Well, carbon can be a +4 or -4 depending on what it's with, but a lot of times that's a perceived charge and it's not an actually called an oxidation state. And so we have to learn to distinguish those two when we're dealing with things like molecular compounds. Okay? So down here is a whole bunch of other elements that make ions, and they're all metals, and they're all positive, and chromium +3 is the common form for chromium, all right? But there's a +6 version. It's a highly toxic version. There's a whole movie on that one. Anybody know the name of it? Aaron Brockovich. You guys remember? Anybody see that? I know I'm dated right here. It was actually about one of the first successful class action lawsuits against a chemical company that won. Okay, and so it's the story of this lady who was very dynamic and, yeah, we'll just put it that way. And so, but it was her story and the relationship to the lawsuit. And so her name was Aaron Brockovich. And so that was to the chromium-6 in drinking water. Manganese.
I know that movie. I know that movie.
Yeah.
It's a really good movie.
Julia Roberts was the character or the person that played the character Aaron Brockovich. Yeah. Yeah, it's a really good movie. It's fun to watch. While you're bored here on campus, you might have a movie night and watch Aaron Brockovich. So if we look down here, here's 2 irons, right? Fe2 plus or Fe3 plus. And so iron 2 or iron 3. The old names for those are ferrous and ferric. Okay? You still see that in our stock room because we still have some bottles that are labeled under the old naming system. Okay? Just like manganese is manganese 2. Okay? Oh, when IUPAC came in and started placing a uniform naming system on all, for example, ions. And I don't know the year, I'd have to look that up. So anyway, nickel 2, copper 1 and copper 2, cuprous and cupric. Then we can have ions. Now if you notice zinc, you guys notice there's Roman numerals there, but there's no Roman numerals on these 3. Why is that? Anybody know? Do I need Roman numerals with the alkali and earth alkaline metals? No, because they only have what? 1 oxidation number. Okay? So whenever you have an element with more than 1 oxidation number, then you have to define what the oxidation number is with a Roman numeral. Okay? So we're going to use that in naming. But this to me is very useful, right, in terms of you guys learning the charges on some of the metals. Okay? Now, the ones I really expect you to know right off the bat are going to be the main group metals here and the non-metals in terms of those charges. That's initially. But then we'll use these enough that you'll learn them. Okay? We're going to have a problem, I know for sure, I think it's in the next chapter, which has both iron 2 and iron 3 in the same compound. Okay? And so we'll start seeing those regularly and work on our naming on those. And so all these slides before this are showing that same information, right? When I have monatomic ions and they're over here in group 1, then they turn into +1. And in group 2, they turn into +2. And when I go on the other side to 17, then those are -1, and to 16, then those are -2. Okay? And that's what this is showing. And So those are the ones that are very straightforward, and that's the maximum negative valence equals, well, 8 minus the group A numbers. But if you use the modern system, you can't use that math. So, but anyway, I look at it from this perspective, and this shows those occurring in that way, right? Plus 1s, plus 2s, minus 1, minus 2s, and then minus 3, and plus 4, minus 4. What is boron? Boron's weird, okay? I'll just put it that way. Can I say that? Yeah. So, we'll work on that. All right. Polyatomic ions. So, those were single elements, right? So, we're talking about single elements. They form those ions on that picture. What's a polyatomic ion? It's a molecular structure, right, that contains more than one type of element that are common, and they have known charges. Okay? And they have known charges. They can range from -1 to -4. For our sakes, right, in this class, we're going to say that ammonia is the positive one, and actually other ammonium containing ions can be +1, okay? But everything else is going to be negative, okay? Everything else is going to be negative. Thank you.
What's the first real laugh you got out of class?
Oh, hey, wow. Years ago, there was a professor here at College of the Ozarks. I'll go on a memory lane right here. And his name was Courtney Furman, Dr. Furman. And Dr. Furman is the only professor that I've ever known to be louder than me. And so Dr. Furman and I, this wall, you guys see the line on that around there? This was actually a vinyl divider. And Dr. Furman and I both like to teach at 8 o'clock in the morning. And so we would be on either side of this, and Dr. Furman would preach. So he was also a pastor on the side, and he would get, oh, we thank the Lord for this, and I mean, really, really loud. You know, when it would be coming through, we'd stop our lecture, and we would listen to Dr. Furman's sermon, right? And he'd really get into it, and so. But I was doing a demonstration, which I'll do for you guys during the semester, and it makes really loud explosions. And so from on the other side of the divider, after about the third explosion, Dr. Furman goes, "We surrender! We surrender!" One of those great teaching moments, right? That you'll always remember. And I do miss Dr. Furman. So. He was a good faculty member. And so anyway, back to our lecture. I'll pull us back out. Sorry about the rabbit hole there. If we start looking at those, here's our ammonium ion. And then, for example, here's a chlorine and oxygen together. Okay? Now, when there's 4 oxygen, that ion is called the perchlorate ion. Okay? Now, hold that because we're going to show some variations with that and help you remember the naming of other ions. Okay? Now, when I look here, this is cyanide, and so -1, both those are -1. Hydroxide ion, OH minus. Now, this would be a base, right? That's the aqueous strong base. Now, if we get into organic chemistry, it's not a strong base, but for our class, it's a strong base. Everything that we're going to do in here, then it works well for that. We have nitrate, right? NO3 -1. You guys recognize these names? You guys have heard of all these compounds, right? Sulfate, so sodium sulfate, for example, and SO4 2-. Carbonate, CO3 2-. Bicarbonate, what's bicarbonate? The modern name isn't bicarbonate, that's what they still call it in the cooking industry, sodium hydrogen carbonate. That's the appropriate name. Either one is accepted for that compound. But if I put an H in front of that, then it's HCO3 1 minus. That's the bicarbonate ion. Okay? And then if I have phosphate, PO4 3 minus, right? If I put a hydrogen in front of that, then hydrogen carbonate, it becomes 2 minus. Okay? So those are all, and there's more, right? There's more polyatomic ions than this. To learn these is really useful in chemistry. Okay? And I'm going to expect you to know, well, for sure this list. Okay? We'll use these regularly. How do you learn them? The best way is just using them, but you may need to flashcard them just to get there, right? To start you on that process. I'm not a big flashcarder, but there's times in my career where I had to do some of that to practice, right? Or when I'm learning guitar chords, new ones, then I do that and I keep that there and try to remember it and then see if I've got it right. Well, it never sounds right if it's not right. So it's pretty easy to tell, but then you have to go back and see what it really is. So it takes that type of practice. But anyway, now when I'm moving on to the next step of this, utilizing the positive ions and the negative ions to make compounds, right? Then there's a naming system for that. And so we would begin in a naming system by picking, let's say, an element, potassium and bromide. Now I'm going to do this backwards. I'm going to go from the name to the chemical formula, right? But we're going to use these rules to do that. And it says name the metal first. So that's the metal name, isn't it? So that's a compound you might be familiar with. And so if I'm writing the symbol for that, what's the symbol for potassium? K, right? And then if the metal has more than one oxidation state, then I need to designate that with a Roman numeral. Is there a Roman numeral in that? No. Why isn't there a Roman numeral in potassium bromide? Because potassium is in the alkali metals and they only have one oxidation state and it is +1. Okay? It's always +1 when it makes an ion. All right? Then we name the nonmetal. So the second one is the nonmetal. What element was this made from? Bromide. Bromine, right? And so the element that made this is bromine. We took the I and E off of it and we put on the IDE. And so this compound is KBr. Now, I have a question about bromine. Where is bromine at on the periodic table? Which family?
Halogens.
It's in the halogens, isn't it? Now, that means its charge is what? It's going to be -1, isn't it? And so when I have a +1 potassium and a -1 bromine, then the joint compound of those, the ionic compound, is going to be 1-to-1, isn't it? Yeah. Okay? So, yeah, that's how that works. And what? Go ahead.
Potassium bromide, is it a liquid or a solid? Is it a liquid?
It's a solid. It's a solid. Yeah, it would be solid. Solid.
Because I was curious because
Bromine is,
a liquid.
yeah, at room temperature. Yeah, that's correct. Oops, I went too fast. You guys know this one? This is your basis for when you get in trouble on the test. You say, what do I know? What's a compound I know? And then use that as a model to answer the question. Does that make sense? So you know the name of NaCl. It is sodium chloride. How about this one? What's Fe? Iron. Okay. So can iron have more than one oxidation state?
Yes.
It can. So now we have to start using some math. Okay, you guys with me? This is literally a math exercise right now. Because I know, well, the other element that's involved is what? Oxygen, right? And so Fe2, so I've got iron, we got that part right. And I need to fill in the parentheses. But what's the second part of the name? Let's put that up there right now. Oxide. And then how many oxygens are there? There's 3 oxygens, right? You with me? There's 3 oxygens. and I'm going to put a multiple sign times, what's the charge on oxygen? -2, and so that equals -6. If I have no charge compound, right? What would I call it, a compound? Yeah. But if it were charged, it would be a complex, right? Be aware of that. Right? I have a compound, it has no charge on it, and I know I'm getting 6 negatives from the oxygen. What does the iron have to be then? I have to get 6 positive charges from it. Right? You guys with me? But if I'm looking up there, I have 2 irons, so I have to split those positives between the 2 irons. So what's the iron? It's +3, isn't it?
How much show did you do?
Well, you can actually do it by math, right? And so what I like to do is I like to set up the math expression, right? 2 times x plus 3 times -2 equals 0, right? What's x? It's +3, isn't it? Simple algebra, isn't it? Can you do this in your head most of the time? Yeah, your brain can calculate these. If you can't, then you can set it up that way. Okay? If you can't, you can set it up that way. So, the appropriate name for this one is iron 3 oxide. How about this one? I threw a curveball in right here. What did I just do? Those first 2 are ionic. What about this one? It's molecular, isn't it? It's got nitrogen and oxygen combined. Do we use the same naming system? No. Okay? So, you see a layer of complexity here. I first need to identify whether it's an ionic compound or a molecular compound, and then name it. Okay? Or polyatomic ion. I have to recognize when I have that, because that's a whole nother set of names. Alright? But anyway, what would be the name of this one? Dinitrogen tetraoxide. How about the following one? Up in the upper right. Potassium iodide. Ionic compound, potassium iodide. Okay? How about this one? What's the first element? Magnesium. Magnesium's a metal, right? And nitride. That is correct, right? If I had nitrate, then the formula with magnesium would be MgNO3. Oops, that's not very good. 2 would be MgNO3 right? So this would be nitrate. I'd have to have that oxygen in there. Or if I had nitrite, I would have one less oxygen. With no oxygens, it would be nitride, IDE ending. Okay? How about this one? It's a molecular compound. So this one is sulfur trioxide. Sulfur trioxide. Cool? You guys got those? All right. Let's talk about polyatomic ions a little bit. Okay? Ate and ite and per and hypo. Okay? The 2 that are shown here are 2 commonly occurring ones. And so you see the nitrate. And if you know the number of oxygens for the nitrate, for example, if you memorize that nitrate is, well, let me just write it on the board by itself. right? And you know this is nitrate. You've memorized that one. Then if you see NO2 minus, you automatically can know the name of that. Okay? Because whenever I have the one less version of oxygen, right? Then it becomes ITE. Nitrite. Nitrate has 3 oxygens. Nitrite has 4 oxygens. Okay? Or if I'm looking at phosphate, right? Phosphate has 4 oxygens. Phosphite has how many? It has 3, doesn't it? Right? So realize that it's just one less, all right?
Did you say I has 3?
It depends on the oxygen is always involved in this scenario, okay? And depending on which element it's with, the 8th form is the common form that occurs lowest energy form, okay? And when I have one less oxygen than that 8, then it will be the ite, okay? And then there's a couple more down there. If I have a hydrogen involved, then it becomes hydrogen carbonate or hydrogen sulfide, right? And or the old language would say bi in front of that, bisulfate or sulfide, bicarbonate, depending on which of those you have. So that's always there, okay? Now I'm going to add a layer of complexity to that with, I want to go to this slide, okay? Because that's where I feel like I should be right now. And so if I'm looking at this, then you see the chlorate. How many oxygens does chlorate have? 3. So that means how many does the ite have? 2. Okay. Now there is a compound that just has 1 oxygen, right? And so it still has the ite ending, but then it gains a prefix which says hypo. Okay. So the hypochlorite is ClO minus, right? The chlorite is ClO2 minus. The chlorate is ClO3 minus. And if I add an additional oxygen, and this is a common compound, perchlorate, okay? Perchlorate, and it's ClO4 minus. And so that per prefix goes on there. So now I can use these with any polyatomic ion series. This is the order that we see. Okay, always. So if you know the 8th form, then you can get to any of the others based on adding or removing oxygens from that combination. Questions? So, common polyatomic ions. I promise you guys that before this course is over, you will recognize these. Okay? By the time you finish General Chemistry 2, we use all of these regularly. Okay? We have a lab which we use our 2 cyanates. Cyanide we don't use much. Hydrogen carbonate or bicarbonate we use a lot. Carbonates we use a lot. We use chlorate and perchlorate in some different experiments. We use the nitrate in many experiments. Environmentally, we can measure nitrite. We use ammonium all the time, right? And hydroxide, well, anytime I want to change the pH to basic, then that's a good choice. Okay? So these polyatomic ions are very useful in our daily life. Here's some more that are useful. The sulfate ion, the hydrogen sulfate ion, the phosphate, the hydrogen phosphate. Well, in fact, one of my favorite buffer systems, and we'll talk about those next semester, is the phosphorus series, and we'll talk about how they work as weak acids and in chemistry to form buffer systems. And so it's maybe in terms of you health science people, some of the most important chemistry to learn. In health, the buffering system of the body makes it possible for us to live. Chemistry is quite amazing. Just in terms of blood chemistry, the pH of blood shifts from the lungs to muscle tissue. It becomes more acidic in muscle tissues. And so that acidity allows the hemoglobin to release the oxygen. The more acidic you become, the more oxygen is released till it runs out. And in fact, your body fights that. Anybody ever heard of lactic acid? Causes soreness, right? And so when you become anaerobic, your tissue starts to produce that, trying to force the blood to release more oxygen, okay? And that's what causes that soreness, is that going to more acidic, right? And so then when it gets back to the lungs, then it becomes more basic, and the hemoglobin becomes sticky to oxygen again, and so it attaches and moves through. And so that is a complex system that's based on understanding the chemistry of phosphate and of the carbonates, which are in that system, and buffer it to where it needs to be. Okay? Well, in fact, CO2 plays a huge role in that too, doesn't it? Because it takes water in your body and turns to carbonic acid, then becomes a carbonate ion. And so we're going to learn a lot of that chemistry this semester. And so, how many people is that talking in chemistry for right there? Yeah. And so when that happens, right, realize that I'm going to try to give you the language to understand that as we move on through the semester. So that's one of my goals. All right. And so that's why this naming becomes important. All right, naming compounds with polyatomic ions. All right, NaNO3 would be sodium nitrate, KSO4, or K2SO4, potassium sulfate. What about iron 3 bicarbonate? What would be the formula? It's right there, but think about it in your brain. What's the charge on the bicarbonate ion? It's -1, right? And so there's 3 of those to the +3 on the iron. You guys can see that in the molecule, right? So there's 3 of those, and it says iron 3 bicarbonate. That's how you match that up. And here's ammonium phosphate, or phosphide, excuse me, I missed. I looked up there, saw PO, and I just automatically went to that one. It's the more common one, but that's phosphide because it has 1 less oxygen. All right. You guys are really pumped up today. Yay, hump day. All right, let's select the correct formula for each. How about aluminum nitrate? Aluminum nitrate, which is one, A, B, or C? Or actually, 1, 2, or 3. 3, everybody agree with 3? What's the ion charge on aluminum ion? 3 positive, and so nitrate is -1, so I need 3 of those, that's correct. How about copper 2 nitrate? What's the charge on nitrate? Again, -1, so that means there's going to be 2 of them to balance the charge, right? So CuNO3, 2, so that's number 2. How about iron 3 hydroxide? Iron 3 hydroxide. It's going to be 3 because hydroxide is charged. It's -1, isn't it? And the iron is +3 in that case. How about, what's that number? 10? Oh, over now? Good buddy? Never mind. That was a laugh. Never mind. 10,4 hydroxide, right? So which one? 1. That is correct. All right. So you guys got these? Yeah. The biggest problem is knowing these. Okay. So, all right. Find the 8 form. Learn the 8 forms. They're all boxed. And then you can go to the hypoite or the per 8 from there. Okay? Alright. How about these? Match the correct one. Where does MgS go? What's the suffix on the anion? Ide, so that's pretty easy, isn't it? How many ides are there? 1. So that's number 3. MgS is 3. How about MgSO3? 1. Magnesium sulfite. Now, if you didn't know its name and you got this matching, could you answer it based on what I taught you a minute ago? Because you know that the 8 is always going to have 1 more oxygen than the ide. And so I could have eliminated and got to that, right? Guys, see how that's helpful on a standardized test? Yeah. So, and obviously if it is 1, then the MgSO4 is the magnesium sulfate. How about down below? Well, let's just name the ions as we go. What's ClO3? You guys remember the name of it? Minus? ClO3 minus? The chlorate. And so that means that 1 less oxygen is the chloride and 2 less is hypochlorite. And so then we can go over and we can match those. And this is the hypochlorite, this is the chlorite, and this is the chlorate. Okay? Now, I do a wonderful demonstration with the chlorate. All right, I use sodium or potassium chlorate to do it, but we can make a gummy bear scream, and we will before the semester ends. Okay? Cool? All right. Oops. Practice naming. What's this one? It's got 2 polyatomic ions. Ammonium nitrate. Yeah. You guys should write these down on your paper before I roll them up, just for practice, right? Yeah. So this one's ammonium nitrate. Don't answer. Write it down. Commit. Potassium perchlorate. Potassium perchlorate. This one would work well to make a explosive device, a strong oxidizer, rockets, those types of things. Calcium carbonate. Is that right?
Yeah.
Oh, I gave it to you before we got there. Sorry, that was unintentional. The next one. That's my clock is slow, I got out early. Sodium hydroxide. Sodium hydroxide. So, this is a flow chart. It may be useful to you or not. I put it in the slide set. I found it a few years back, and to just kind of get a train of thought. It's up to you whether you use it or not. It just goes from metal or non-metal, and it asks some questions to get to where you're going. Okay, so just let you know that. All right, we're gonna go to a chemical equation. I still got a couple minutes, right? Don't get too big a hurry. I got a minute. So, yeah, we'll quit there. Thanks, wait a minute. Wow. Thank you guys. Have a great day. Find some energy.